You have the setup for any triangle. Law of sines deals with the angles and the sides opposite them. This is for non-right triangles. Okay. Remember, when we're doing law of sine stuff, law of cosine stuff, all of our angles are going to be in degrees, so you make sure you have your calculator set to degrees. So law of sines, if you guys recall, showed that the sine of an angle is to its side opposite, is the sine of some other angle to its side opposite, is to the sine of the other angle to its side opposite. And obviously you're not solving with all three of them all at the same time. You're going to switch between whatever is given and working your way out of it. Law of sines works whenever you have an angle and its side opposite. That's kind of the trick. You always use law of sines when you have an angle and its opposite. And you can solve the triangle that way. Okay. You guys remember law? This one's law of sines was pretty quick. Excuse me. Real easy example then. Oops. So it wasn't right out. So we have angle C is 102.3, angle B is 28.7, and little b is 27.4. I know. Such a jerk.
Sorry.
Okay. No. So what doesn't this problem have?
A little c.
An
Or an A.
Or a big A, or a little a, or a little c.
Does it have to what? A. Nice and happy.
Yeah,
That's me after that test.
How about a picture?
Let's draw.
Oh.
You can draw one.
I was joking, that's nice to have an A.
No, I know, but I just, yeah, it'd be real nice to get an A on that.
Be nice to have an
Does it matter that it's not drawn to scale?
No.
No, Lord no. I like to draw pictures and just put it up there. That way I know where my opposites and stuff like that are, so it's a little bit less difficult to screw up. Not to say that you can't, but you never know. Usually, when you have triangles, when you're dealing with law of sines, or eventually we get to the law of cosines, you're going to know 3 of the 6 parts. When you have 2 angles and a side, it's really, really easy to find the third angle. Because what do they all have to add up to equal? Very good. So that's how you can find angle A. So what I would normally do when I'm doing law of sines, law of cosines, I'm going to make a little list of things I need to find. I'm going to find little a, little c, and angle A. Whenever I write out angles, I put that angle symbol there with the capital. And I know it's sometimes with the capital letters, it's tough to see that. But at least here they have the degree symbols. If you forget to put a degree symbol in there, it's not the end of the world, because I'll forget 80% of the time.
Yeah, I made sure I had all degrees on all my stuff this year. Oh, yeah.
Well, it's chemistry, because if you don't have the right units, things blow up. Math, if you don't have a unit, it's just math.
Physics stinks.
Anyway, so do you have an angle and its side opposite?
Yes.
Yeah, which one?
B.
B. So usually I also do this kind of oversimplifying it. I know I'm going to use this as my pivot. I'm going to use that to solve for little c. And I'll use that to solve for little a. Okay.
Do they have to do
Mm-hmm. So sine of 28.7 is to its side opposite, as the sine of 102.3 on your FM dial is to C. Oh no, fraction equal fraction. What do I do? Cross multiply. Remember, the sign of 28 and change is just some crummy number. So how do you undo multiplying by some crummy number? What was that? Did you just make up a word?
I think it was like multi.
It was
divide.
both multiply and divide at the same time. Multiply.
Moldivide?
Multiply, I guess.
So you mold it over to divide? Yes, we divide. You just put right in your calculator the fraction bar. Type it right in like that. Don't worry about parentheses or anything. Create a fraction bar, type it in, and you're good to go. Make sure you're in degrees. Okay.
Let's see.
Whoa!
5, 2,
Hey, are you allowed to get negative? It was charging. Okay, we now say no, I'm not.
The settings, I can't.
Hey, did somebody else give me a calculator yesterday that was charging? Or this might have been a spare.
Mr. Murphy,
I'm still not.
are we your only section of pre-calc?
Yeah. I have one, which Fontana has the other two.
I feel like we are.
What do you guys get for little c?
55.75.
55.75?
Yep.
So now it gives you your little c. And now we have to figure out angle A. Well, what was 28.7 and 102.3? 131. What's left for angle A then? 49. And I do the exact same setup with the 49 now to solve for little a. Remember, one of the things that you can do to check if you're in the ballpark-ish, largest angle will always have the longest side length across from it, smallest angle at the smallest side, and so on. That way, if you're getting that little a winds up being bigger than angle or bigger than little b, and you know you've done goof. Well, it will be bigger. Sorry, smaller than little b. Then you know you goofed. All right. It's just little things like that you can try out with that. Another thing that I would say is that yes, you could reuse that side and angle of C to solve for that. But what happens if you screwed up on C? Then you're going to screw up on the next one. Try to make sure that you reuse your given values as you're solving these types of problems. I think we probably said that a lot last year in trig when you're doing your SOHCAHTOA stuff. By reusing your givens, if you reuse something and you were wrong, if you use something that was wrong, again, you're definitely going to be wrong. But if you reuse something that was given to you, you have a chance of being right the second time around. So reuse your givens if you can. Does this vaguely ring a bell?
Yeah.
Absolutely. You remember using it for the degrees?
But then I changed it. No, not 63, but 63.
No, it could be right.
What?
Because it's smaller than.
So it's little a. Calculator said, I thought I had a charger at home, but I didn't.
I do.
Are you in degrees, sir?
I am in degree. What is going on? Concentration.
But I don't need it now.
No.
Well, let's be honest, I just use that.
Yes, sir.
Does the calculator have showing negative numbers?
It's supposed to be degrees, and that's not.
No, because I had the same problem.
I'm trying. You have to reset it to get.
Did you get 43.07? Oh, like when it's
Oh,
together.
here's why. Once you get to that, you have to. Once you set it to degree, you have to click on OK, and then go to your document,
Or you,
I really don't.
and now it should work.
You said.
Why is it not resetting itself? I'm here.
boy.
Settings. Settings.
I think I changed it to the document that you were in.
But,
And you got the same.
you know,
You're next. Okay, yeah, and then like some of the guys like on the baseball team are like working on my softball team. They're like, oh, don't get my car, you attacked my car. And so we're like, because they are. And then we were like, and we said, then like, we just kept responding with you're next. Like, did we get Ben? Did we get Ben Johnson? No, it was Jake.
You got it.
Joke's
on you, I don't care.
I was taking partners before we came out.
I was gonna say, go ahead.
What'd you do? I got that. I already did that.
Plus blood.
I don't have a car door, so.
I don't have a car door.
Oh yeah, with all the wisdom.
How do you get your car back?
Yeah, but then I'm gonna not jump. He has to get into the passenger side.
I used to do that for the longest time. Like, try to, like,
45 degrees in the first. That's it.
That was a good picture.
Just say, because you're just like, we were giggling halfway through speaking. And then actually,
I'm taking chances.
right?
Not a good though. No, that is perfect.
It's like 9/11 minutes.
Iron sharpens.
Barbed wire. I don't fucking know. Tell me, dude.
Like you sharpie do purple iron instead of iron, so that means like it's like there's a
I have no idea why it's not out here.
whatever.
I'll figure it out. Let me show you guys the other quick example here before we get
I
too
know
far
what I
along.
was saying, and then like it basically means that like you have
What
to
they
be-
will do,
if
actually
you play
we'll come
well,
back to
they'll-
this one on Monday. Sometimes do not even attempt to read and or memorize any of this. When you have the possibility in law of signs, sometimes you run across what's called the ambiguous case. The ambiguous case of law of signs deals when you have two sides and an angle. Okay? Two consecutive sides and then an angle. What happens is that depending upon the angle, when you do law of signs, sometimes it will work, sometimes it won't work, And sometimes when it works, you can have 2 triangles. Now there's a long process by which to test, but it's a waste of time. It's very, very easy to use law of sines because of the cross multiplying. It's also very easy to find a supplement. How do you find a supplement of an angle?
180 minus.
Subtracted from 180, okay? So if you've got a 50-degree angle, its supplement would be 130. So what we do here is that I have a shortcut that works for the law of sines for what we call the ambiguous case for testing purposes. It's very, very nice and easy. So for those of you guys that, we did it last year where you just bounce it off the supplement and it works real quick. Those guys that didn't do it that way, you probably saw the long method of listing out all the different possibilities. That's a pain. There's no reason to do that. Law of sines is a very quick way to solve triangles, and if we continue to use that, it's easy to show how it can happen. So for example, if we use this, and I left myself a note to show you the shortcut. I have 2 sides and an angle, side-side angle.
Can we do the?
Do you see a right triangle?
Oh, shoot.
No, the triangle's right. I'm not. I'm not very good.
No.
2 sides and an angle. The angle is not between the 2 sides. When the angle is between the 2 sides, you gotta use that law of cosines. We'll see that next week. So here you set up your law of sines. It's forcing you to find which angle. B. Because you have little b, so it's going to force you to find big B. So you have the sine of 42 is to 22. As the sine of b is to little b. I don't need to do a lot of cross multiplying here because it's already in the top, so I just multiply by 12. So I get 12 sine 42 divided by 22. I hate the resets. Oh, I don't want any of this. Just give me hide that. Thank you. This is all I need. Okay. All I need is this. I'm going to create a fraction bar. I have to do a little bit different than what you guys set it up is. And I go 12 sine 42 over 22. Okay. Make sure I'm in degree mode. And hit enter. That equals the sine of angle B. How do you undo a sine? Inverse.
Sine -1.
So now I know second sine of that answer. That calculator, I think you just hit the same sequence, but you hit the trig button to go through it. This is going to give me my angle. 21.41. I go to 2 decimals. You okay with that? So angle B is 21. So now I have my 2 angles. 42 degrees, 21.41 degrees. Since this is a side-side angle case, and my original angle was a cube, hi! What I'm going to do is I'm going to check to see if there was a secondary triangle that could exist. And I do that by checking the supplement of angle B. What's the supplement of 21 and change? 158.59. That's the supplement of angle B. If I take my original angle of A of 42, can I make a triangle? No. So there's no 2 triangles. That's it.
What is 2 triangles?
You can get 2 triangles in the law of sines.
So if it did equal 180.
If it was less than 180, that meant that I could have had there could be two triangles. And I'll show you an example.
Okay.
Okay. When you're dealing with the ambiguous case, in your first angle is acute, and you have the two sides, it goes side-side angle. That angle is acute. When you find your second angle, you always check to see if the supplement can create a second triangle. If it can, great. If not, don't worry about it. This case means this is too big to make another triangle, which means that I'm only going to have one triangle in this with this case. That's all it is. Okay? I'm just checking the supplement. So then I would go through and say, here's 21.41. Now I can find the leftover for angle C and go on. Before we run out of too much time here, let me show you the case where it does occur when you check that supplement, how you can see that you're going to get that second triangle. And I'll come back to this problem to show you why this one won't work, because it's easy to see. So I dump back into the other one. If I try this one again, side-side angle. Same deal. I've got little a, little b, and angle A. It's forcing me to find angle B. Okay? Force me to find angle B. I set up the law of sines to find angle B. Sine of 20.5 is to 12 as the sine of 12, sine of angle B is to 31. Bringing that over, I'm going to get 31 sine of 20.5 is to 12 is the sine B. Find B. Some crummy decimal. I get 64.78 for angle B. The supplement of 64.78, 115.22. I'm going to call that angle B prime, just in case it does create a second triangle. Okay. All I do is I check. If I take that 20.5 and I add it to this one, is there enough degrees left over for a different angle C? Yeah, that's why I can get two triangles. That's why that works. Does that make more sense now?
Yes.
That's why I'm doing that. That's why I'm checking to see. I'm bouncing it to the supplement, because remember, when you're dealing with sine, where's sine positive in the graph? First and second quadrant. So there's another angle over here that shares the same sine value from the first quadrant that's over here because it's obtuse. There's an obtuse angle with a sine value that's positive, whereas cosine values that are obtuse are negative. That's why this works. You're just checking the supplement to see if it works through the second triangle. That's it. So now you know that you have a secondary triangle. You have one triangle with 20.5, 64.78, 12, and 31, or 20.5. Oh, thanks. You should cut that one. Sorry. Or you get 20.5, angle B prime would be 115.22.
Answer C.
And then you'd have a different angle C. Okay? So you're going to have two different angles for B, and then two different angles for C, and two different side angles for side C. That's all this is doing. It's bouncing it around to the second quadrant so that there's an obtuse angle that has the same sign. That's it. You check to see if the supplement can create a second triangle. That's the trick. So if I go back to the other one, again, the reason why this one didn't work is because I had my supplement was 158. If I added that to the original angle of 42, it was too big. There weren't enough degrees left over. It was already over 180 degrees, so it wouldn't work.
So just one.
Right, so it means it's just one triangle.
Okay.
That's all.
So we would still have to find C.
Oh yeah, you still gotta find C. But this is how you would test to see if you're gonna have one or two triangles. And all you're doing is bouncing it to see if the supplement works. Okay? The supplement works. And when the supplement works, we call it prime. Because it's like the secondary version of it.
Like I'm
Exactly. It's more than meets the eye.
What the heck?
This is sound effects. Okay.
So are we kind of done with like all the stuff on this?
No.
You're never 100%.
This chapter 6 is still tricky.
There's imaginary trig, remember? Are we actually doing that?
Yeah.
Try.
That's 6.5. Once again, turn the page then.
That's gonna be saved for tomorrow.
Well,
Or Monday.
paper's cheap.
True. The entire thing. I just started a new notebook.
Which angle is this forcing you to find first? It's forcing you to find angle B again. So we do the sine of 85
No, I thought so.
is 215. And the sine of angle B is 225. Set it up, you get 25 sine 85 divided by 15 is the sine of angle B.
Should they find the angle of B like the majority of the time or just
It just happens. I get 1.66. When I inverse my sine, what happens? Doesn't work. Can you take a sine? Can you find an angle? Will an angle ever have a sine larger than 1?
No.
So this means this triangle does not exist.
So what do we just do?
No, no triangle. So remember, sometimes when you're dealing with that side-side angle, the ambiguous case, if your first angle is acute and you've got the other two sides, you could have one triangle, two triangles, or no triangles. When it comes up where you try to take the inverse sine of a value that's larger than 1, that means the triangle does not exist. Because you can't have sine value larger than 1. Because of the way that the unit circle works. Because the sine was never larger than 1. It all comes back to it. It comes full circle. What goes around comes around.
No. Dorothy, you're the funniest person.
I sense the sarcasm.
Alright, next yes.
Okay.
I should have seen that.
Okay.
You know, the one where you're putting on the sunglasses? Yeah, that one.
Yeah.
And she's like,
a
he has
so
hair.
that's a capital
And I was like,
delta.
oh.
Do your day one stuff.
Why did you say that? Didn't you shade it to that girl?
Yeah, they did the St. Baldrick's 7 years ago, this past spring, and I did it. Yeah, I just shaved my head. Fontana and I did it. We raised money for, bless you. It was, what was her name? Swimmer girl.
Grace?
Grace, thank you. We did it for Grace, so did that, and I got home, my wife's like, I like it, and then it just stayed like that.
My dad shaved his mustache after I didn't see
Yeah, we
him.
did
Like,
inverse sine.
I never saw my dad without his mustache.
Because what you're doing right now is trying to figure out what angle is the sine of that, so you have the inverse of that. And then you have the inverse of that.
I'll do it.
To see how it's on the final.
I mean, I can't grow it right.
So if you see that, if everything else was all set up right, if it's greater than 1, you didn't goof, Just no triangle.
Okay.
Yes, guys.
So are we in on the